Okay, guys. Lesson 3.1. Okay, we are talking about polynomials. We're going to start by talking about what a polynomial even is, how to classify them. We're going to look at graphs of them. So a little bit of everything here. So first of all, definition. Polynomial is the sum or difference of one or more terms. And those individual terms are called monomials. This is vocabulary you would have heard back in Algebra 1 somewhere.
Yep,
The words are not new. You may not remember them exactly, but you've heard this vocabulary.
I've heard polynomial.
Okay, so sum or difference, basically polynomial, multiple terms added or subtracted. Now, the specific about those terms, each term or a monomial, it could be a real number, it could be a variable, so a letter, or a product of real numbers and variables with whole number exponents. So when we talk about this, for instance, 5 is a monomial. Okay? X is a monomial. Or when we talk about product of real numbers and variables, we can talk about 5x cubed. Okay? These are all examples of individual terms or monomials. A polynomial are these pieces added and subtracted together. Okay? We could even talk about something like xy to the fourth. Okay? These are all just individual terms that can be added and subtracted together. A bunch of these added and subtracted together is a polynomial. Now, one thing we're going to talk about is standard form. When we talk about standard form of a polynomial, officially here it says arranges the terms by degree in descending numerical order. Largest power to smallest power. So when we go to put these in standard form down here, it's all about the powers. Okay? When we think about a quadratic, we usually think ax squared plus bx plus c, right?
Yeah.
Same idea. Highest power to lowest power. We're going to talk about the degree of a polynomial. The degree of a polynomial is the greatest degree, or in other words, the largest power. That's going to be our degree. And then we're also going to talk about leading coefficient. Leading coefficient being the number in front of that highest degree. So the non-zero factor multiplied by the greatest power of x. And the easiest way to do this is for me to go through the examples with you, because I think the examples will make more sense than the words do. Okay? Now, I put this chart on here so you can be familiar with the vocabulary. Although, when I was going through the Savas homework, they didn't necessarily use this vocabulary. They just went by numbers. I was kind of surprised. But when we talk about the degree, for instance, one that you're familiar with. If I say something is a cubic, that means it's going to have a highest power of 3. Okay? We just came off a chapter dealing with quadratics. Quadratics have a highest power of 2. Linear,
1.
that's 1. Okay? I don't know that we necessarily talk a lot about constant, but constant would have a highest power of 0. A new one to you, quartic, has a highest power of 4. Quintic probably sounds a little more familiar. Highest power of 5. So those are some vocabulary terms. We talk a lot about quadratics in here. Not so much about all the others, but... And then, how many terms? If there's one term, for instance, like 5x cubed, that's an example of a monomial, because there's one term. If there's 2 terms, such as 3x minus 7, I'm just making examples up here.
Binomial.
It's a binomial because there are 2 terms. Trinomial?
4x plus 3x to the second minus 7x x.
No. I don't want to put another x. I've already got x there. I almost took it fully. Okay, so Gatlin's trinomial here, 4x plus 3x squared minus 7. In other words, it's 3 pieces added or subtracted together, right? Okay. Once we get anything with 4 terms or more, does not have a specific name. Okay, so there's just generic there.
the whole polynomial 4 terms, would that be
No.
like would 25 be as? Would that be as
No.
1?
One.
Or would that be a 2?
That'd be
There's two
monomial.
numbers there.
25 is one number, though, if you're saying 25.
Oh my goodness. Okay, so 3x squared minus 4x minus 7 equals 0. Is that
No, no equals, just expressions.
okay?
Just
Plus 4.
What did
What we just wrote plus 4. That's a.
You're going to have to throw in another power.
4x plus
If that's the same
3x
power, then
squared
they can
minus
add together.
7 plus 7x to the third.
That's why she couldn't say 7x.
Right.
Yes.
So,
That's why when I said 7x was wrong.
Now.
They're not helping you.
okay, listen up, guys. So, I wasn't necessarily going to, but you guys want an example there. So, there's your example of polynomial with 4 terms. And you'll notice as we do these, guys, the idea here is that each term is unique, right? If there are like terms, we would go ahead and put those like terms together. And we're going to talk about those down here in our examples. Okay? So let's look at A. We're going to start by asking what each polynomial is in standard form. Standard form going from highest power to lowest power. And then we're going to talk about what the leading coefficient, the degree, and the number of terms are. Okay, so example A is negative 4x plus 9 plus 2x squared. If I rearrange that and put it in standard form, standard
2x
form
squared.
being largest power to smallest power.
2.
Go ahead, Aaron.
2x squared minus 4x plus 9.
Okay. 2x squared minus 4x plus 9.
Yep.
That's standard form because the first is the x to the second. That's the highest power. Then the next one is x to the first. And then the last one doesn't have an x. It's just a constant term. Okay. Notice it's a negative 4x, so that negative was carried to make it minus 4x. Keep the signs as they are. Okay. Let's talk about the leading coefficient. So, actually, you know what? I think before I talk about leading coefficient, we're going to talk about degree. Let's see. And I might as well just write this here while I'm here. Number of terms. Okay. So we're going to talk about leading coefficient, the degree, and the number of terms. Let's first of all talk about the degree. So the degree of this is the greatest degree or the highest power among its monomial terms. What's the highest power here, Landon?
X squared. So.
Okay.
2. I don't.
Nope, that's so highest power is going to be that degree of 2 right there. Okay?
I gotta remember that.
Now, leading coefficient. Leading coefficient is non-zero factor that's multiplied by the greatest power of x. Okay, what was my greatest power of x? X to the second, yes? Leading coefficient. What's the number out front of that? 2. So this 2 right here is my leading coefficient because it's the number in front of the highest power.
The number
Okay.
of terms. Oh, that's so.
And then number of terms.
Trinomial.
Don't, guys, be calm.
Trace.
Count up your terms. How many do we have?
3 points.
And there are 3. Now, officially, I am going to agree it's a trinomial, although from what I saw in Savas, unless I, the couple I clicked into just asked for number of terms would be 3. They didn't ask you to put trinomial.
I got the next one.
Okay? Okay. Questions on this one?
No ma'am.
Shotties like a minute.
Okay. Let's look at example B.
That's so easy.
Okay. Standard form. Remember, you're going from highest power to lowest power.
Ooh,
You have to be careful with those signs. What do you got, Gatlin?
Wait, what do you mean signs?
Just make sure you keep the correct
okay.
positive or negative sign with the term.
I got it.
Aaron, quiet.
Yeah, quiet here. It's 3x to the 5 fifth, whatever, minus 5x to the third plus 2x.
Now, did you say it and I missed it?
No, you didn't say it.
What kind of term is 3x to the fifth?
I said that.
No, you didn't say it.
No.
Listen.
Okay.
No, you didn't.
Guys, seriously. I appreciate being involved, but keep it under control here.
Yeah.
Okay, standard form. 3x to the fifth is your highest power, so it's negative. Negative 3x to the fifth, then minus 5x cubed, plus 2x plus 6, because my powers go 5, 3, 1, and 0. Now, I think this time I'm going to switch up my order. And I'm going to ask about the degree first.
Degree.
What degree is this problem here, Leighton?
5.
Oh, yes.
5.
That's right.
Okay. It's a degree of 5 because the highest power in the problem is 5. Now, if the degree is 5, and I'm abbreviating here,
3.
Negative.
what is my leading
Dang
coefficient?
it. Negative 3.
Negative.
Okay.
I told you.
Dude, that's my
Has to be. Guys, come on. Seriously. Degree is 5. Leading coefficient is the number out in front of that term. So negative 3. And number of terms? How many terms do we have here? We have
4.
4. Okay. Basics, yes? I'm not doing anything too fancy.
Are these?
You have to watch out for the, the places they'll try and trick you, but
Questions like this on our homework?
yes.
These are pretty easy.
Okay, C. Standard form. Our given is x squared plus 2x cubed minus 3x squared plus 4x cubed. What's your thoughts, Landon?
You want me to? I combined like terms, and I got a final product of 6x cubed minus 2x squared.
Okay. So did you guys catch what he said there? Combine like terms. The question is not, does 4x cubed or 2x cubed goes first? It's not a matter of which x cubed goes first. It's a matter of those are like terms we can put together. And 2x cubed and 4x cubed is 6x cubed. And then our squareds, x squared minus 3x squared is going to be minus 2x squared. So yes, anytime you see like terms, make sure you put the like terms together. Okay? Okay. 6x cubed minus 2x squared. What degree is this polynomial?
3.
Has a highest power of 3. What is our leading coefficient then?
6.
The number in front of the x cubed term is going to be the 6. And then, number of terms. How many terms do we have, Aaron?
2.
2. Make sure when you answer that number of terms question, you're not looking at the original. you're looking at, okay, after we got it cleaned up and in standard form, that there's 2 terms there. Okay? Questions there?
Oh man,
Can we handle that?
that's pretty
As
good.
I said, there are questions like this on homework, believe it or not. Okay?
Pretty good, easy.
Okay. Before we go to the back, we're actually going to talk about this chart down here at the bottom. Ooh. And it copied a little blurry, unfortunately, but I don't think it's too bad.
Yours are
Actually-
colored.
Yeah, why is your color? That's not fair.
Because I can save a file in color, I can't copy in color. So,
Adults get food.
But- okay. Okay, guys. Now, we're going to spend some time talking about in behavior. And in behavior is what a graph does in the end. So what does a graph do as it goes off to the left and as it goes off to the right?
It
goes.
Okay? And we have information about this based on your equation. So I'm going to pick one, and I'm going to pick this one right here. An example of this one is y equals x squared. What do you know about the graph y equals x squared? What's that look like?
is that on the second one?
That's a parabola, right? That's that U-shaped parabola. Yeah, I'll go back and talk about the first one in a moment. But the idea here about in behavior, if we just think about a parabola, as my graph is going off to the left, so what we would say is as x approaches negative infinity, as my graph goes off the left, where's my graph going?
Up.
It's going up, right? And so my y is going up to, anytime my graph goes up, we say that y is going up to positive infinity. What about as my graph goes off to the left?
It
Or,
goes up.
excuse me,
The right.
as my graph goes off to the right?
Positive.
Then my graph is going up again. And it's going up to positive infinity. Okay? So this right here, notice we have the example showing that the 2 ends are going up. This will happen anytime you have an even degree. So in this case, my degree was 2, right? If we have degree 4, degree 6, degree 8. Anytime we have an even degree, and my least coefficient is positive. So notice it's a positive x squared. My graph on the ends is going to, both ends are going to go up. Okay? My last Algebra 2 book called this up and up.
Up.
Because it would be going up on the left and up on the right. Now, the opposite example. I'm going to come down here to the last one for a moment. What do you know about the graph y equals negative x squared? Y equals negative x squared is a
Points down.
upside down parabola, yes?
Yes.
Okay, well, degree is even still, right? X squared is even. And then the leading coefficient is
Negative.
negative. Well, in this case, a graph with those characteristics will always go down on both sides. And again, my old Algebra 2 book would call this behavior down and down. We're going to use infinities. If it's going down, it's going to be going down to negative infinity. Okay, and we'll talk about this on the next page. So those are examples when your degree is even. So if you have x squared, x to the 4th, x to the 6th, x to the 8th, one of those is your highest powers. Now, what are the other 2?
They're odd.
Odd. So, I don't know, do you guys remember what y equals x cubed looks like? You guys remember what y equals x cubed looks like?
Is it?
Or I could use y equals x, would that be better? Y equals x cubed,
Line. Oh. Yeah.
is that squiggle thing there? If you'd prefer, we could use y equals x, because what's y equals x look like?
That.
But notice, x cubed and x, those both have what kind of powers?
Odd.
An odd power, yes? Powers of 1 and 3 are odd powers. And notice, the graph in both cases, it starts in the left corner, it starts in the bottom left corner going down. And where does it end in the top right corner? it ends going
Uh,
up. Anytime you have an odd degree, so 1, 3, 5, 7, 9, so on and so forth, and a positive coefficient, it's going to have this behavior. Now, what's the negative going to do to these graphs?
yeah.
It's going to flip them. And so our last example would be, so if we talk about y equals negative x cubed, again, looks something like that, right? Or would you guys maybe prefer y equals negative x? Okay. Y equals negative x being the negative slope there, right? So in these cases, 3 and 1 are both odd degrees, right? Both cases, my coefficient is negative, and in that case, my graph is going to start in the upper corner, so going up, and end going down. That behavior will always be true, and we can always tell this based on what our highest power is and whether that term has a positive or negative coefficient. Now, we're going to put this information to work here. Okay, so you're probably going to have to flip back and forth because, unfortunately, the way my notes worked out, they didn't end up on the same page. Okay. Use the leading coefficient and degree of the polynomial function, so what we just talked about, to determine end behavior of each graph. As I said, my last book used just the words up and down. This book, we're going to talk about whether it goes to positive infinity or negative infinity. Okay? Now, as you look at A, give you a big long polynomial. F of x is 2x to the 6th minus 5x to the 5th plus 6x to the 4th minus x cubed plus 4x squared minus x plus 1.
That's crazy.
What's the only piece of that that really matters?
Well,
The first one.
Right here, guys.
Yeah, that's the leading coefficient.
Okay? We just have to know what degree this is and what type of coefficient this is. So 2x to 6 is the only thing that really matters. What do you know here about this term?
It is positive.
Okay? Out here, the 2 in front is positive,
It's an even exponent.
and it is an
Right.
even exponent.
Really not doesn't matter.
Okay? That's what you have to know. Do the rest of those terms even matter?
Nope.
No. You just need to find the term that has the highest power and use that. Now, look back at your chart.
Look back at.
What does this mean if this is an even degree and a positive leading coefficient?
It is up and up.
It's kind of like y equals x squared, isn't it? My graph, now, it doesn't mean my graph specifically will be U-shaped. It could be. But it means that the ends of my graph will be going up. Okay? So keep that in mind. This first question says, as x approaches negative infinity. So which direction are we talking about here? As x goes to the left. Okay? When it says as x approaches negative infinity, as your graph goes to the left, where are my y values going? They're going up. Where is up? Is that positive or negative infinity? That's positive infinity. So your answer here is going to be that y approaches positive infinity because it's going up. Okay? So when we say positive infinity, that's the fancy form of saying up. Now,
Bless you.
the second half of this question. As x approaches positive infinity. So that's saying as my graph goes to the where?
Left.
No.
right.
Losing attention. I'm sorry.
as x goes to positive infinity, so that's saying as my graph goes to the right, where's my graph going? It's going up. And what is up?
Y.
Y approaches
Oh gosh.
positive infinity.
Yeah.
So it's the same answer in both cases. Okay? And that's because both sides of my graph are going up. Have I made sense of this so far?
Feels good.
What's he saying, Grandma?
Okay. Let's go over here and try B. G of x equals negative 5x cubed plus 8x plus 4.
Negative and odd.
What matters here?
Who's putting all the math books in the horror section?
Okay. We know that right here, my highest power is
3.
3, which is odd, and the leading coefficient is
Negative. Negative.
negative. Now, what do the ends of my graph do then?
Down.
So, like this.
If it's odd, it's an up down or down up. And if it's negative, that means it's going to start up
Ow!
and end down.
Listen.
Okay? So, my first question. As x approaches negative infinity, that's saying as we look where on the graph? Where's x approaching negative infinity?
Left.
That's the left. So as my graph goes to the left, where's my graph going?
Up.
It's going up. And how do I express up?
Down.
Y is approaching infinity.
Y approaches positive infinity.
Y approaching infinity.
Now, as x approaches positive infinity, so that's saying as we move where on my graph?
Right.
Down. Right.
As we move. Okay? And here's the deal, guys. They're not going to say left or right on the homework, are they?
Nope.
This is why I'm trying to put it into easier terms for you. They're going to say as x approaches positive infinity, where's my graph going?
Down.
It's going down. How do you think I express down?
Right arrow.
Negative infinity.
Y approaches
You said negative.
negative infinity.
You need real though.
Okay. Okay. If you're catching on here, guys, your answers on all of these are either going to be y approaches positive infinity if it's going up, or y approaches negative infinity if it's going down. Okay? It's you do have a 50-50 shot, which means on Savas
You just guess.
you probably get one chance, and then they're going to give you a new problem. Would be my guess. So,
Wrong. Wrong. Wrong.
okay. Let's look at C. H of x is 2x squared plus x to the 7th minus 6 minus 5x. What important information can you identify here?
X7.
Why is he talking about x7?
Because that's the highest one.
Okay. Does 2x squared matter in this term?
No.
No, you have to look for the highest power. My highest power is 7,
Oh, daggone.
I already said that.
and 7 is odd. What do we know about the term x to the 7th? Is it positive or negative? It's positive. So, be aware, again, they might not be provided in order, right? Okay, so, did you look on the front?
Yes, by
What do we know about if it's odd? It's either down, up, or up, down. If it's positive, there's your visual, right? Okay, so as x approaches negative infinity, what am I asking you? As we look where? Where's negative infinity in terms of x?
Left.
Okay, as we look at the left side of the graph, where are we going? Where's our graph going?
Down.
Down. And how do I state that? y approaches
Negative infinity.
negative infinity. As x approaches positive infinity. What am I asking you? As we go to the
Right.
right. As we go to the right, where's my graph going?
Going up.
It's going up, and so my y values are approaching
Positive.
positive infinity.
This is easy.
I tend to agree. Now, you guys realize this whole left, right, up, down business, you guys have connected. We're talking about the x and y axis, right? Because your
Oh my goodness. What am I gonna do?
okay, x-axis runs horizontal. In case you haven't made this connection. So when I talk x going positive or negative infinity, that's when I'm talking left or right. Y-axis goes up and down. Okay, example D. J of x, 5x minus 3x to the fourth. What matters?
The highest.
So it is
Even.
even and
Negative.
negative. Even and negative? Well, even is like a parabola. Negative is like an
Line.
upside down parabola. So, where are both sides of my graph going?
Both going down.
Both going down. So what are both of these answers?
The y arrow negative infinity.
Y in both cases is going to approach negative infinity. We don't even have to think about which way they're asking me, because in both cases my graph is going
Down.
down. Okay? Officially, when x goes to negative infinity, it's left, and over here it was right. Okay. Use the chart when you go to do homework. Okay? And I think this section, these pieces on homework should be pretty easy. Okay? If not, come talk to me tomorrow, right?
Okay.
Yes, ma'am.
I'll talk to you.
Okay. Last part is sketching the graphs. Now, we sketch the graph. Back in chapter 1, we talked about what it meant for a graph to be positive or negative and increasing and decreasing. I don't know how well it sunk in, but we talked about it.
Oh yeah, it's not.
So, here's a blank grid, and here's some information.
Gritty.
This graph isn't going to be very specific, but we're going to sketch a graph. Now, I'm going to go ahead and let's see. As I kind of scan through here, I think we need to go as high as 4 and as low as -4. So I'm going to label just the x-axis up to 4 and down to -4.
1, 2, 3, 4.
Okay? And our goal is to sketch a graph. It's not going to be precise. It's not going to be exact. We don't even have an equation. So it's not like you can even put this into Desmos. You have to go based on their clues. Now, if the graph is positive on these intervals, if a graph is positive, where does that mean it is? That means it is above
Above the x.
the x-axis. Okay? So when a graph is positive, it's above the x-axis. So from negative infinity to -4, my graph is going to be positive. Which means what happens at -4? It's going to cross through here. Okay? It's going to be going, and I'm just going to kind of put a line there indicating it's going to be going up over there. And then from -1 to 4. So -1 to 4, where's my graph going to be?
Positive.
It's going to be positive. And I'm not going to draw the whole thing yet because we have a little bit more information. But those lines are just kind of me indicating that, okay, it's going to be going that direction. Does that make sense?
This should be a graph.
Now, if the graph is positive means it's above the x-axis, what does the graph being negative mean?
Below.
Whoa.
In these intervals, my graph is going to be below the x-axis. So, okay, this should be the other places, right? From -4 to -1, my graph is below the x-axis. And from 4 to infinity, my graph is below the x-axis. That kind of makes sense with what we already have thinking, doesn't it?
Okay. I follow.
Now, if a graph is decreasing, what's that mean it's going to be doing? It's going to be going down. It's going to be, this graph is going to be going down from -infinity to -2.67. Well, where is -2.67? Somewhere in there. So what that's saying is that this graph is going to be going down to about -2.67. This graph is also going to be going down from 2, which where are we at 2? We're up above here, right? So from 2 to positive infinity. Those are decreasing segments. They're angling down. Is the next part going to come together then?
Connect your line and make a Z.
Okay. What does increasing mean? My graph is going up. So from -2.67 to 2. My graph is going up. Does that make sense?
Yes, ma'am.
I'm below -2.67, above 2.
About this.
It's a swell. It's an S.
And it looks something like that.
Ass.
That's based on the clues they gave us. Now, does your graph have to look exactly like mine?
Yeah.
Not exactly. Maybe your minimum here goes lower. Maybe your maximum goes higher. Okay? You have to look at what they give you. Now, I'm going to try and talk through the last one real quick. Homework is out there on Savvis and should be available and will be due tomorrow. Okay? What do we say positive meant? Above. So from, I think I only have to label out to 2 on these. So I'm going to label 1 and 2, -1, -2. So from -2 to -1, we're going to be above. And from 1 to 2, I'm going to be above. Right? Negative means we're going to be below. So from -infinity to -2, we're going to be below. From -1 to 1, we're going to be below. And from 2 to infinity, I'm going to be below. Now, the important part, if we're increasing here, we're increasing to a maximum. So I'm going to increase to above -1.5. And I'm going to increase from 0, which keep in mind, 0 is going to be down here. It's going to be below, right? And we're going to increase from 0 to 1.5. Decreasing, we're angling down. So from -1.5 to 0 and 1.5 to infinity. Okay? Give it a try in Savvis. Lesson 3.3 or 3.1 due tomorrow. See me if you have questions.
Chicken nugget.
Woo!
Oh, we got my cat.
Yeah, it's together.